Thank you very much. Let's see, is this on? Yeah, I guess so. And this is my business partner, Rich Cameron. And at the moment, my literal right hand. Because I broke this yesterday, so I'm going to be kind of managing a little bit here. But anyway, so what I'm going to talk about today is just where is 3D printing now? And go ahead. And so you're all probably familiar with the Gartner hype cycle, right? You know, things go up and up and up and up, and then they go, to use a technical term. And then they kind of level out, and then they go up, and then they hit a stable point, right? So 3D printing will sort of ask for a poll at the end of where it is in the hype cycle as far as you're concerned. But clearly, there was up. So first to start with that, what's a 3D printer? How many of you here have a 3D printer? Yeah, well, you don't count. But anyway, if you don't, 3D printers basically are motorized hot glue guns at the consumer level. They build up objects one layer at a time. The piece gets bigger as you work with it. If you ever work with a CNC, the piece, you start with a block and the piece gets smaller. This way you're building things up a layer at a time. So there's usually some kind of platform. You're laying up a model like this, and you can build pretty intricate things. And we can pass this around. I'm going to take that and pass around. That's a model from our new book. So you can build pretty amazing and pretty intricate things. Go ahead. So where does this field come from? 3D printing has been around since the 1980s. It was mostly a couple of big companies that had industrial big machines. They had patents, so they elected to keep the companies, higher end industrial, higher margin. Now what happens, all those patents ran out. And so people like this guy. But before him, there was this guy named Adrian Boyer who said, you know what? The patents are all running out. I'm going to put out a 3D printer that can make 3D printers, put it out open source so people can evolve it. And so that was the beginning of this explosion of 3D printers. So that's 2 or 3 years? 2 years between them?
2 years.
So Rich did one of the original open source printers. That's the Wallace. And this is a Deesmaker Bakito, which is, he's 2 or 3 years in between. So you can sort of see how rapidly that evolution took place in that universe. Go ahead. So if you haven't seen a consumer printer, they look something like this. Since we were literally shorthanded, we didn't bring ours today. We were at, our background is we were both at Deesmaker, which is this company, and then we spun out our company, which we'll talk about. But they work off something called filament. It looks like weed whacker wire, but isn't. But it's sort of, that's give you the general demeanor. And a couple of different kinds of materials and stuff, which if you're interested, I could talk to you about later. But basically, they all work something like that with a lot of variations. And so the model, in this case, this platform moves like this. This arm here moves like this. And then this whole arm goes up or down to give you the third dimension. And they're all variations on that. Go ahead. And the variations spread out. So this is me with one of those Bakito that Rich designed. This whole thing here is also a 3D printer called the Part Daddy that they take out to maker fairs and stuff. And they don't sell it. They always say put a price on it just because people kept asking, and he didn't actually want to build and make another one, so he paid what, $100,000 or something like that. So they do make a kind of consumer printer, but they made that one just to make a point. Go ahead. So a lot of this was fueled by crowdfunding. And so 3D printers got to kind of a consumer point about as the Kickstarters and Indiegogos and that stuff got sort of reputable and some power behind them. So here's some of the biggest crowdfundings. So the very biggest was in 2014, that was a micro. Form 1 is a different technology out of MIT that you print out a bed of resin. Buccaneer was a very cheap printer, as was RigidBot and PrinterBot. And the Peachy, those are Canadian dollars, about which more in a minute. And the local interest is the Mod T. The first column is how much they raised in their crowdfunding, and the second one is sort of where they're kind of the middle of their rewards, if you're familiar with crowdfunding sort of their I sort of guessed at what their mainstream reward dollars were. So local interest, Monty and the CEO's here, raised $683K, and Deesmaker had 2 crowdfundings that were that. Go ahead. So this took off, right? You know, there's sort of like a new 3D printer every day, it seemed, and all this kind of stuff. And so inevitably, this had to shake out. So here's what happened. So of those, you know, you can look at the statistics there. We'll get to what scandal means in a minute. But all 3 of the local ones, Make It did not do a crowdfunding, but I have it on there just for completeness. But all the local ones survived. Buccaneer, you see, had a very, very low price point, and they raised a lot of money and failed to deliver anything, which happens. The PG printer, very innovative printer, and we can tell you about it some other time, but it's basically a grad student in Canada, and he had this idea that you could have a vat of saline solution and a little layer of resin on top of it, and make this printer really, really cheaply. So what ended up happening is he got an investor who took his crowdfund raise, which was $600K, and bought a house to flip, and failed to flip it. So it's all tied up in Canadian courts at the moment. So that's what scandal means. So this, you know, a naive kid, right? So this stuff happens. So this is, you know, if you look at it as business, you know, businesses, how many of these businesses in tech survive? It's not bad, right? But, you know, that's sort of how it's worked out. Okay. So what has happened? And we heard a little bit of this before. So what have been sort of the things that have moderated the hype cycle a little bit? One is that the expectation of a lot of people who buy printers is that you just hit print. And it's mostly not that way. Mati is probably one of the closest ones to that. And if you do have a simpler printer, you're going to do some trade-offs that you won't be able to do some things. You do some things very well. Printing takes a long time. That white flour that's being passed around is about a 4.5 or 5 hour print on a Bakito, which is a pretty fast printer. Some artists don't like the lines. You can always see the layer lines on a 3D print. Some artists don't like that. And so you need to do some post-processing labor. So you may print something pretty quickly, but you know, it's that extra time it takes some. I didn't really talk about other technologies. Instead of filament, you can also have a vat of resin that you shine a light from a digital laser projector on, and you'll get a layer hardened up at a time. So there's a lot of those out there. There are also ones that work with powder. The metal printers are big vats of powder that are sintered by a laser. The little problem with the metal powder machines is that powdered metal is explosive. So those machines are still in the, what, $500K to $1 million or so range, mostly because they have to be argon fed so that they don't blow up. Blowing up's bad. But if you're, you know, if you're doing something where you're doing very complex parts, aerospace parts, it's worth it. But it's not, those are not consumer things, at least not yet. Go ahead. So the question is, now what? So, you know, so we're here somewhere, right? So what we did was we decided that no one was really teaching people how to use these. And we were going to call our company Now What, but that was too dépassé and somebody already had the website. So instead we called it Non-Scriptum, which is Latin for unwritten, which we figured was close to Latin for Now What. So what we do is we teach people how to use these technologies. We go out to schools or university labs or places like that, and we say, all right, you know, here's what you've got. Now what? You know, how can you use it? We also write books. You can. My lovely assistant will wave our most recent book there. 3D printed science project. So what we've been trying to do is to say somewhere between having to learn absolutely everything and just taking a model someone else has built for you. There's a middle ground where maybe you have some models to 3D print that you can vary and change and things like that. And so we're also developing that along with APRESS and some books and curriculum. So we're doing that. Some folks have focused on sales and support of a lot of different printers. So Matter Hackers is a marketing partner of ours. They do a lot of open source printers of the heritage that Rich's printers in. Purple Platypus sells a lot of the more industrial machines. There's a group called Organovo that doesn't sell machines, but they make human tissue using their machines, which they keep internal and trade secret, I assume. So they are down in San Diego-ish, Encinitas, something like that. They're on the road to San Diego. There's people who have gone to models and services. So there's several of those that basically you mail them a file, they'll print it on expensive machines. There are some services that are basically Uber for 3D printers. These two are that. So if you have a 3D printer and you want to make some extra money, you sign up with one of these services and you print things for people. That might mean as a consumer that if you farm out your job to them, that it might be a 9-year-old making his printer money, which might be okay, because he might put 10 times as much work as somebody else. But you just have to, that's how it is. So that's an interesting business model. So 3D Hubs and Make XYZ are out there. And some of the original players are still in the industrial ones. And there's some printers that really are going for a specific market, either for the home market, very specifically, the home market with kids. We were trying to think of some other specific ones, but things like that. Go ahead. So, and there's just a shameless plug at the end. So these are some of the models that we have in this new book, which we've, this is Design a Plant. So these are basically very similar models with a few numbers. These are different models, but they evolve from each other. The idea is you can evolve a plant. We have if you already have a printer, the couple of dollar wind tunnel model, you stick it on a postal scale, you blow a fan on it, kid can measure lifts and get an understanding of it. We have some things about levers and simple machines, which is a big deal in 8th grade. Go ahead. We also have a public project that we're trying to get going with our friends at Hackaday, who have a space that way. And so the LA Unified Visually Impaired, teachers of visually impaired, blind kids teachers, have come to us, and of course they don't have any money, but they would like to find a way to get models that they need to teach blind kids design. So we put up a project on Hackaday, and we're going after what's called the Hackaday Prize to try to get this to happen. So if anybody's interested in that or talking to us about that, we'd like to get a lot of schools and groups like that involved in designing these models that people need to teach blind kids, because the 3D printing is almost perfect for that. Go ahead. So where to learn more is we have 4 books out with a 5th one coming, and we have some handouts with our books. We do online classes through Learn Network, which is outsourced online classes. We consult one-on-one. We come out to sites and say, you've bought this, now what do you do? And that's how you get a hold of us. And in Innovate Pasadena tradition, I have 2 asks, because for those of you who are new, you can do an ask. It's something you need here. So we're looking for, we don't do enough classes to have a class space of our own, but we're looking for somebody who might want to host some of our professional development classes for teachers. So we're looking for a space somebody who already has classroom space to work with on that. And for the next 4 weeks or so, I need a ride. I need to live near the corner of Allen, Washington. So everybody does that. Okay, so questions?
Thank you so much for that, Joan. We're going to open up to Q&A. John is going to walk around with the mic. If you're new to this experience, questions now, comments later. Will you stick around for some extra discussion and storytelling and all that stuff?
I won't even watch anybody. Yeah.
There you go. Nice. Okay. John's going to walk around with the mic. If you have a question, raise your hand.
All right. Who would like to start?
Uh-oh. That's a ringer question.
Hey John, thanks for the presentation. I'm curious what your assessment is of areas for the greatest growth over the next 5 years within 3D printing. Is it going to be home use, educational use, market-specific use, or continued industrial, medical aerospace?
I'll cheat and say, how many people think that we are on the downside of the hype cycle still in 3D printing? Okay, how many people think that we've turned back up into the stable part? I would be about there too. And then so part of the answer is, I think it's still waiting for the killer app. I think education is will get big once there's content, which is why we're in the content space. I think the medical space will get big once people solve a lot of materials issues, because there's a lot of issues with FDA clearing of some of these to have a surface that's sterilizable is a little challenging with a 3D print. So there's a lot of issues of sterility. If people can figure out how to do food safe entire chains, I think that would be interesting. And in aerospace, the powder printers in aerospace will just keep going because that's a very good application. And aerospace people are set up to have explosive things around. And that's just sort of how it is, right?
Thank you for the presentation. Two questions for you. One is somebody who's interested in starting out, recommendations as to where I can go other than to the guy to my left, or maybe to the guy to my left, as a kind of consumer level way to start out. And the second question is, as a father of somebody who is addicted to Minecraft, in any of your little demos there, is there the export model to Minecraft?
Yes.
Because I thought that would be
Tinkercad.com has export to Minecraft, so that's a non-explosive question. If you have a home 3D printer, the guy sitting next to you is a good option. If you want more options than that, Matter Hacker sells, I think, 60 different ones. So that's my hair-splitting political answer. Yeah.
Hi, my name's Tyler. I'm in the real estate industry, and I've heard they are building houses on 3D printers in China. You heard about that? And if you have, what's going on with the quality of these printings?
There is controversy about there are stories out about that. There is controversy about whether those stories are true. You want to take that?
Yeah, so there have been several projects actually to build houses and other small buildings with printers. The Chinese story in particular had some fishy things about it, but yes, that is something that's being worked on.
And there's people trying to make concrete printers, and so that's a thing people are working on.
Actually, to add on to that, I also heard that one of the ways they can colonize Mars is to send a 3D printer out there and use the natural materials to build something rather than to spend or send it by rockets.
Yeah, the Hawaiians actually have been doing some research for NASA because Hawaiian regolith looks a lot like Martian and lunar regolith. Hawaii has volcanoes, right, which is pretty similar. And so the Hawaiians have actually been playing around with making their concrete simple things like walkways with regolith, with lava 3D print, basically. It's ground up stuff in a binder. They're not melting it to lava. They could. I guess Hawaiians also are used to very hot things too, but they've been playing around with regolith printers, and there's some people at University of Hawaii who are interested that they could probably find pretty easily.
Back here.
I'm a high school teacher librarian, and I went to my principal and said, all the cool librarians have a 3D printer, and he got me one, so now I'm cool. What do you think is the biggest takeaway for education and 3D printing?
I think the biggest one is that the printer is the first part and getting trained is the second part. So that's what we try to do, is to train people to actually use them, because it's not 100% obvious out of the box how to do that. So chat with me afterwards.
In the beginning of your presentation, you talked about how 3D printing is essentially old technology. Can you talk a bit about your perception of the patent system and how that's affected this technology's ability to spread?
If we had all day, I'd let Rich answer that question. I'll preface this by saying I used to be a JPL tech transfer person, so I was sort of on the other side of this. I have now come over to the point of view that patents are bad, full stop. for everything. Because the patent system is so badly broken that people are being given patents for things that overlap with each other. And so it's basically a giant forest of litigation. And so I think an argument for open source, we're open source fanatics, for want of a better word. I think an argument for open source is how rapidly the technology developed after being pretty much not evolving very much for 30 years. In the space of a few years when it was out there, open source, it took off. And so, you know, I know there's people in the room that have patents, but my view after seeing a lot of this is that particularly for small companies, you know, the reality is if a big company wants to break your patent, they'll just do it. That's my opinion. I am not a lawyer. I am an opinionated non-professional. But in 3D printing particularly, I think patents held the field back. And hopefully they will not be a forest of new ones holding things back again. I shouldn't overshoot the microphone, I just saw hands back there.
Hey Joan, I'm Amy Winslow. We work a lot with new consumer products for large volume sales. So you and I have had a little bit of conversation about this, but we see challenges when people get a 3D printed model and then they try to go to a factory and have it produced, because the additive process is so different from what you would do to produce something in volume. Can you speak a little bit about that?
So, you know, coming back to this business that 3D printing is slow. You probably do not want to 3D print for more than, you know, we usually say about 100 to 1,000. Once you get above that, you probably want to start thinking about making a mold. So for the kind of things you're talking about, 3D printing is very useful for making a mold. And it's also useful for iterating at the beginning. I mean, you can have a printer in your office here and a printer in your partner's office in New York, and you can just ship files back and forth and print things and have them and look at them, and that's a powerful thing. And I think a lot of early adopters were architects because they're all around the world, they're very visual, they kind of know the CAD tools already. You know, the barrier for most people is learning the CAD tools, and the CAD tools are very design tools. And those tools are getting better, and there's starting to be drag and drop ones that little kids learn in half an hour or less, and adults learn about 2 hours. So there's starting to be a lot of tools. The tools are by and large free, by the way, so there's a lot of free tools out there too. If anybody tries to sell you a tool, try the free ones first.
Hi, Joan. I'm behind the post. Yeah. It's good to see you up here. I remember seeing your D's maker for a long time. I have a question about the role of libraries and maker spaces in getting the consumers using the 3D printers. I mean, the cost point is pretty low, but then you commit yourself to one particular model, and with all the ones out there, it may not be the best one for your uses. Do you see the increase of use of public libraries as a place people would go to do models or maker spaces, or do you see that as a kind of last year's story?
Well, I think we are certainly seeing a lot of that. You know, I think the big challenge is that people like to donate hardware to schools and libraries. They don't like to donate training. As somebody was saying when I was talking to them earlier, you know, we can't put a plaque on training easily, although I've been offering up Rich for that. But you know, what happens is people like to donate hardware, but then they don't donate, you know, how are you going to use this and how are you going to learn it? And teachers in particular are busy, and it's not trivial most of the time because the modeling part isn't trivial. So that's one reason that we've gone into this space of creating curriculum which has models that can be varied and also have some real solid material behind them, so you can learn, you know, about how do plants grow and how do plants add biomass and stuff like that in our plant one. So that you're not starting from cold at zero, having to say, what kind of model do I make today? Or there are big databases of models you can download, but who learns anything from that, right? You download it and it's like, you know, those things that used to be pressing a penny at the, for those who were my age or older, you pressed a penny in the amusement park. Well, you know, it's fun and everything, but then what, right? So I think, you know, a lot of it is how do you use the technology for its real promise in teaching people, and I think that's the challenge right now. And I think to this point it's been about let's buy hardware, and now I think people are taking a step back but then a lot of them have spent their money on hardware and now they're sort of stuck. So we're trying to figure out our own business model in this, and we're also looking for opportunities for grants, but we're for profit, so we have to partner. So if anyone wants to partner on a grant, that's another ask. Anyhow.
Next question.
Good morning. Thank you for the information. So I'm in the middle of renovating my old house, and I found someone who actually is going to help me to do 3D printing for some of the decorative items like corbels and things like that. But he and his son actually have been focusing on the entertainment industry in printing guns for those guns enthusiasts. And it's amazing in terms of what they can do. What's your view as far as this technology bleeding, or as already has bled, into an area that could, I guess, damage or, questionable in terms of safety and health and environmental, for society in general?
I think people were talking about what improves the field. The guy who made the gun probably did the most damage to 3D printing of anybody, because we've had a lot of schools say we can't have 3D printers because kids will make guns. That's the commonest reason when I was a Deesmaker that a school would say no. Maybe it's changed, I don't know if it's changed since then, but that was sort of the big thing. And now there's this guy who has the best-selling book about, was it Take It From Me or something like that, about his adventures in Manifesto. So the reality is that you can make a gun out of anything. And so I think this guy sort of said, well, I'm going to make a gun and attach it to this thing that's climbing the hype cycle, is the reality. It's a 3D printed gun is probably more likely to kill the person with it than the person they're shooting at, is the reality. And so it's kind of a red herring and sort of frustrating those of us in the field, because it's perceived as this big thing, but the reality is you can make a gun out of anything you want, right? And 3D printing is probably a pretty dumb way to do it. But unfortunately, it's sort of, somebody linked the two things on the hype cycle together, and that's just unfortunate.
For those in the audience, especially for those in the audience who have kids that would like to get into 3D printing, what's the easiest entry point, or what would you suggest as a way for them to
We have these books. That's not entirely a silly answer. We were at a 3D printer company, and the big thing that was that, particularly for the open source 3D printers, there was a ton of material out there, but there wasn't sort of an entry point. And so mastering 3D printing's been out for a long time. It kind of a long time in this world, about 2 years. Well, that's a long time. And so, we had that book mostly aimed at that. Matter Control is the other book is 3D Printing with Matter Control, and that's an open source operating system that's common to a lot of the printers that are open source. And now we have our 3D printed science projects, which is intended to be kind of a starting point. So that's the intent, is that we try to write these books. We also have online classes, and we also come out and do staff trainings. And so that's what we're trying to do, is help with that right now.
Now, are these books pretty easy for the average person to be involved? Because I remember I had visited Deesmaker. They have one of those open forum type things, and they had a class to learn about 3D printing. And the class was taught by a middle school kid. I don't know if you know what I'm talking about.
That was an Arduino class, actually. Yeah. That was Q Techno, who was a 14-year-old. Actually, now he's 16 or something terrifying like that.
Hi, my name's Peter. I'm a designer and developer. I know some of the software involved, but I was wondering, since you brought up erring on the side of open source software to start out, what are the top open source softwares that you'd recommend?
Depends on what you want to do. For kids, Tinkercad, which isn't technically open source, but it's free. It's tinkercad.com. And for educators, all of the Autodesk products are free if you're an educator. So that a whole line from Tinkercad is the simplest up through Inventor and more sophisticated things. We do most of our stuff in an open source program called OpenSCAD, which is sort of a C Java-like based language, so it has things in it like Spear and Cube and stuff like that, and so we like that. And we also, I haven't used it, Rich has used a little bit, Onshape, if you want to do more, which isn't open source either, but it has a freemium model and it's pretty cheap. Any of the open source ones that you?
Well, there's always Blender, which
Blender.
is a real old open source 3D program. It's kind of doesn't have a learning curve. You just have to know it.
You have to you join it. You don't learn it. You join it. You become one with it. No, it's used for feature film movies, and it's open source, but it's pretty scary. It has the Blender cheat sheet is like the size of that poster over there. So people who are good at it are really good at it, but I've always said, yeah, next lifetime. Oh, you wanted to more in the back.
Right here.
My name is Ray. I'm the teacher. I was wondering if you have some high-level bullets that I could try to convince the school to buy a printer and some reasons why and how to get started.
Well, how to get started is easy. I sold that one, right? I can give you one of our cards. Yeah. I think the key thing is that it lets kids design something that is a little more sophisticated than, than they would otherwise. Thank you. I think if you have a robotics team, very often the gateway for buying a 3D printer is a robotics team, because they can print out some things that maybe they couldn't make otherwise. So if your school has a robotics team, very often the early adopter is the robotics team. The issue there is that the robotics team usually needs something a little more sophisticated than, say, the history department does. So I think the adopters that have been the most comfortable have probably been science departments in our experience. Science and art, which is sort of a surprising combination, maybe. But the science department is usually needs stuff and needs visualization things, and so they're usually open to spending some time doing that. And then the artists, more and more, are comfortable with CAD. We have a 3D printer artist here in the front row, so he could tell you about that. Second row.
Stress, yes.
So I think it's that you can do some interesting things that maybe otherwise you would have needed to use full-up shop for. We have a book called New Shop Class because of it.